Welcome to homework.
So problem 515, we have oil leaking from a tanker and they show us a table here. So R of T, this is my rate. So what I have here in this column is the rate of the oil leaking, and the units are liters per hour. And then they also give me at a moment in time what the rate is. So the top row that you see here, this is my time given in hours. So I don't see, this is not the volume of oil, it's the rate at which it's leaking. So at 0 hours, I'm losing 8.7 liters per hour. At 8 hours, I'm losing 5.3. So we're asked to find the lower and upper sum estimates for the amount of oil. So in order to do that, I've got to figure out, okay, you have to know a little bit about the shape of the curve anytime you start dealing things with area here. So if I look at these numbers, 8.7, 7.6, it looks like every time these numbers are going down. So if I look at, if I could construct what's going on here, this is a function, if it were continuous, it would be a function that would be always decreasing. So what that would mean is if I drew a rectangle and used the left endpoint, so if I use the left endpoint, that's how I would come up with an upper sum. If I use the right side of a rectangle, right there, you can see that that would give me a lower sum. Okay, if the function changed from increasing to decreasing, I would have to go and reflect that. But in this one, it makes it easy. It's always decreasing. So I know that my upper sum is going to be my left sum. So if I look at my upper sum, it's just going to use all the left sides of the rectangles. So what that means is I'm going to use, it's going to be what, 0 times 8.7. And if you look at the distance between each one, so the width of the rectangle, so that first rectangle, sorry, I need to choose the width of the rectangle. So the first one, not 0, back up. Let me just erase that. Each of these is 0, 2, 4, 6, 8. The width is always 2. So what we're going to have here is, if we look at this real quick, the width of each rectangle is 2. So you're going to have 2 as the width of each rectangle. And then the heights of each rectangle, if I'm using the left side, it's going to be the numbers 8.7 plus 7.6 plus 6.8 plus 6.2. And let's look at that real quick. And sorry, I left out a number on here. Let me back up. I left off the number. There was one extra number here. So sorry about that. The number at 10, and it still is decreasing at 5.3. And the one that you have right before it is 5.7. So again, if I'm using the left side, just double check that. The left side is going to be 8, 7, 7, 6, 6, 8, 6, 2, 5, 7. So 6, 8, 6, 2, 5, 7. And that should be it. So 1, 2, 3, 4, 5, 6. 6 endpoints. So that should give me 5 intervals for that. So 8, 7, 7, 6. 6, 8, 6, 2, and 5.7. This turns out to be 70. So this is going to be 70 liters. So that is my approximation as an upper sum. Now, if I do my approximation as a right sum, so that's going to be the sum for the lower, and we establish that that's just going to be using the right side of each rectangle. So still the width is still 2, but the first rectangle starts at 7.6. So you get 7.6 plus 6.8 plus 6.2 plus 5.7 plus 5.3, and that's how I get the lower sum. And this turns out to be 63.2 liters is my approximation there. So you can see that if you have an upper sum, you expect it to be higher as an estimate than your lower sum. And that is what I see reflected here. So again, I don't have a continuous curve here. In previous problems, you had to plug into a function. Here I have discrete data. So I'm limited here in what I could do in terms of I can only evaluate the data at the discrete places that I have. And so there's the difference with the upper and the lower sum.